All right, so we're going to finish the lesson up, and we're going to do this one in your notes. We're also going to put the notation for reflection. So we're reflecting the same figure over and over and over again. You're going to graph it, either graph them separately on graph paper or on the same grid. If you run out of space, it doesn't fit on your the figure doesn't fit so well. We can just kind of estimate it. If it's really too difficult, I guess we can leave that one out. But let's try to get them all in. All right, so the x-axis, that would be our x-axis. By the way, so it doesn't get too visually confusing for you to look at, I'll do each one on a separate page. So reflect over the x-axis. This one you have to kind of estimate a little bit, because we're going to go right off the coordinate plane. All right, so A here is at 2, 1. A prime will just be the opposite. Excuse me, I shouldn't say that. The y will be the opposite. All right, so we're going to keep the x, make the y the opposite. So A prime here is located at 2, -1. C is at 4, 1. C prime is at 4, -1. And B is the one who has trouble fitting in here. So B here is located at 4, 5. B prime should be located way down here somewhere at 4, -5. And then we'll connect. And there we go. First one's done. So just kind of draw it a little bit below. Let's go on to the next one. The y-axis. So this would be R and then little y-axis. All right, so this time we're going to keep the y's, make the x's the opposite. All right, so 2, 1 becomes -2, 1. Here. So that's it. -2, 1. And C was at 4, 1. That's going to be at -4. Oops. -4, 1. And finally, B, this one fits in pretty good. All right, so B here is located at 4, 5. It's going to be located at -4, 5. So right here, from best I can see on these lines. All right, so here will be B prime, -4, 5, and we can connect. All right, so notice mirror image. Notice whatever was closest to the x-axis or line of reflection on the image, pre-image, is the same part that's closer on the image. And boy, that's a horrible looking triangle. Let's do the next one. X equals 1. So the notation would be R x equals 1. All right, so x equals 1 is right there. All right, so now we don't have any handy dandy rules, but I don't think we'll have any trouble counting. I don't even think we need to subtract. All right, so A is 1 away. A prime is also 1 away. All right, and then so this will be the point 0, 1, and this was 2, 1, and this was 4, 1. Actually, let me color code that. 4, 1. All right, so reflecting over our line here, and this was x equals 1. All right, so 4 is 1, 2, 3 away. I got to count 1, 2, 3 away right there, and that is -2, 1. All right, that's going to be C. And finally, B is also 1, 2, 3 away, so it's going to be 1, 2, 3 away. And you can kind of even just count in your head. All right, so 4 minus 1, that's 3. So go another 3. And there we go. There, and this was B prime. And this is -2. This was 4, 5. This is -2, 5. And there's our image. All right? Let's do another one. Now we're up to y equals 2, and now we're going to have, oh, actually y equals 2 is okay. Y equals negative 2 would be a really big problem for us. All right, so y equals 2 is right here. The coordinate notation for that is r y equals 2. All right, so A here is, I'm going to write it again, 2, 1. It's 1 away from the line of reflection. Count 1 in the other direction. All right, so that's 2, 3. So notice when you reflect over a horizontal line, your x coordinates don't change. When you reflect over a vertical line, your y coordinates don't change. All right, and that's A prime. So B is 1, 2, 3 away. We're going to go 1, 2, 3 in the other direction. There's B prime. So this was at 4, 5. This one is at, still at 4, but now it's 3 away in the other direction. All right, so this is 3, negative 1, or excuse me, 4, negative 1. And finally C, 1 away, just 1 way this direction now. So this was at 4, 1. Now this is at 4, 3. And now we can draw it. And so notice whatever was above before is now below. And there we go. There's our reflection. 2 more to go. So this one's relatively quick. Y equals x. This would be the notation. Or y equals x. All right, so we'll draw our line of reflection. All right, so it has a slope of 1 and goes through, whoops, it's really hard for me to see, and goes through 0, 0. You don't always have to draw the line of reflection for this particular reflection. I am, just so that you can see it. All right, so A here is located at 2, 1. For A prime, I'm just going to put it over here. So A is 2, 1. A prime will be 1, 2. And B is 4, 5. B prime will be 5, 4. And C is 4, 1. C prime will be 1, 4. That's all we have to do. All right, that's how easy it is. All right, so 1, 2 right here is A prime, and B prime is at 5, 4, 1, 1, 2, 3, 4. So it's over here, right? Because B is on the other side. So B prime is 5, 4. And then C is going to be at 1, 1, 2, 3, 4 right here. Right? And so C prime is 1, 4. Right? So you could draw a line perpendicular, but like if you try to draw it on this one, you might have trouble because the coordinate plane is so light. Here you don't have to when we have coordinate plane and we're reflecting over y equals x. Just remember, switch x and y. Switch your vertical and your horizontal distances. And there we go. There's our line of reflection. Right? So if you looked at this little part here, right, it matches with this little part here. All right, and we can see we have the correct image over the line of reflection. Also notice that if I connect corresponding points, notice it's that line there is going to be perpendicular to my line of reflection. All right. So just other ways that you can find that. Last one. And actually I have one little thing after that, but it's really, really quick. All right, so reflection over y equals negative x. All right, so this time the line goes this way, goes through 0, 0, but now it goes down left to right. And it's really hard for me to see because I really can't see these boxes very well at all. All right, so here is my line of reflection. I do want you to draw it in so you can see it. All right, and then let's reflect. All right, so this time, so A is at 2, 1, A prime, we're going to switch and negate. So -1, -2. B is at 4, 5. B prime will be at -5, 4. And C is at 4, 1. C prime will be at -1, -4. All right, let's graph this. So -1, -2, it's right there. Oh, excuse me. I went -1, -1, +2. So by drawing the line of reflection, I accidentally graphed the wrong point. I wrote it down right. We can clearly see, ooh, that's wrong. That's not flipped over that line. But that looks much better. A prime is right there. So notice if we connected those, right? See how it's perpendicular. Well, if I could draw a straight line, whoops, I did not mean to do that. If I could draw a straight line and put my, that makes such a big point. So that was at -1, -2. There we go. Let's not mess with it. All right, let me just fix that. Right there is A prime, and let's get B prime up there, -5, 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Wait. -5, -4. Both going to be the opposite. So I had to leave that one off. If you make that mistake, it's really clear you're not reflecting over the line of reflection. 1, 2, 3, 4. 1, 2, if I can't see. I think it's right over here. I hope you see this better than I can see it. There's B prime. 1, 2, 3, 4. No, I counted too far. 1, 2, 3, 4. That looks better, I think. All right, and then C is at -1, -4. Right, so 1, 2, so 1, 2, 3, 4. Guess there. And let's connect. Oops, got a little glitch in the board and lines I can't see. All right, but if it wasn't for the glitch in the board and the lines I can't see, we have a good reflection. All right. And I think this is just a little too, oops, high. Let's just move the, oh, I know why it looks so bad. When I move this thing, I move my line of reflection. There we go. So we moved the coordinate plane. I moved, and the line of reflection didn't move. So I'm like, looks really off. That looks much better. All right, so now if we were to draw a line perpendicular, right, we would, so it would go here, 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 right, perpendicular to our line of reflection, and look at that, we connect our corresponding points. And that's not bad for a figure that looks that bad. So obviously I have a glitch right down there. All right, but yours will look so much better because it'll actually be a triangle. I guess if I used a line tool, maybe we could make a better triangle. We'll do that because right now it looks like a flag waving in the distance. There we go. All right, now we have our triangle and we've reflected over the line y equals -x. The last thing we're going to look at very, very, very quickly, because this was a little bit longer than I wanted to oh no, I guess that's, I thought I had one more thing. I do. Oh, it's next. It's after this. Here it is, line symmetry. We're going to do this really quickly. So a plane region has a line of symmetry, L, if its own image is a reflection, right? So if it has a line of symmetry, that means if I reflect over that line, right, I get the same thing again. I will tell you that one of these figures here, the equilateral, triangle, circle, rectangle, rhombus, square, parallelogram, ellipse, and regular hexagon, one of them has no lines of symmetry. Which one do you think it is? Okay, think it in your head. One of these, actually two of these have two lines of reflection. See if you figured out which of them have two lines of reflection. One has three lines of reflection. See if you figure out which one that one is. One of them has 6 lines of reflection. And one has an infinite number of lines of reflection. Do you think you know who's who? Let's find out. All right, and so you have the definition in your notes, and I had one example. So you better figure it out. Rectangle has 2 lines of reflection because I drew that one in your notes. But let's look at the other ones. Here we go. All right, and I'm going to have you add something to your notes, and that is right here. Okay? And that is, the more regular the polygon or figure, the more lines of symmetry. Figures with no congruent sides or angles have no lines of symmetry. All right? But that doesn't mean if you have a pair of congruent lines that you'd have a line of symmetry. But however, if all your lines are congruent, then yes, you do. All right, so the one that had none was the parallelogram. All right, that will not map to itself. I'd have to turn it around to get it to map to itself. All right, so this is going to end up over here, and this is going to end up over here. No lines of symmetry. The ones that had 2, the ellipse, the rectangle, the rhombus had 2. Oh, I guess we lost our square. The square has a whole bunch. We'll draw him in. We'll come back here and draw him in. The triangle had 3. The regular hexagon had 6. The square had 4. See a relationship there? So 4 congruent sides and angles, 4 lines of symmetry. 6 congruent sides and angles, 6 lines of symmetry. The one that had infinitely many was the circle. Nothing's more symmetric. Right? And so for regular figures, add this to your notes too. Regular figures, the sides equals the lines of symmetry. Regular means all sides congruent, all angles congruent. And for the square, you can pause if you need me to, but I'm going to do this. The square, here were the 4. All right, so, oh, I said 4 lines of symmetry. That's not right. Oh, yes, it is. 1, 2, silly me, 3, 4. Oops, that wasn't very straight. 3, 4. I was thinking about 4 sides. However, the sides are kind of like across from one another. I intersect them twice. Well, you can see this, that it would be if I could draw that straight. All right, so we would have this triangle maps to that triangle. So that one does have 4 lines of symmetry. All right, and that is the end for reflections. The next Nearpod will be translations. Bye for now.